The impossible assignment, the station. That never sleeps, deep in the Kepler system, mining station Kepler 7 hung like a metallic spider against the star-speckled void. The massive structure harvested rare minerals from the asteroid belt, its mechanical arms constantly reaching out to grab floating chunks of valuable ore. Inside its rotating habitat rings, over 300 beings from 12 different species worked together in what the Galactic Mining Consortium proudly called the most successful interspecies operation in known space. Marcus Chen pressed his face against the observation deck's reinforced viewport, watching another load of titanium-rich asteroids being processed by the station's automated systems. 3 months ago, he had been working on terraforming equipment back on Earth. Now he was the only human engineer on a station filled with beings whose ancestors had been traveling between stars when humanity was still discovering fire. The soft hum of the station's primary engines vibrated through the deck plates beneath his feet. That sound had become as familiar as his own heartbeat, a constant reminder that they were surrounded by the deadly vacuum of space. Without those engines powering the gravity generators, atmospheric processors, and magnetic shields, everyone aboard would be dead in minutes. When giants fall, silent chief engineer Vorthak materialized beside Marcus with the characteristic shimmer of Zephyrian teleportation. The crystalline being stood nearly 3 meters tall, his body composed of living mineral that sparkled with internal light. Vorthak had been managing engineering operations on Kepler 7 for over 2 centuries, longer than humans had been using steam engines. Engineer Chen, Vorthak's voice resonated like wind chimes in a gentle breeze. Your presence is required in Engineering Bay 7. We have encountered what your people might call a significant problem. Marcus followed the towering crystal being through the station's main corridor. The walls here displayed a living timeline of the station's operations. Holographic displays showing mining yields, crew rotations, and system status updates in dozens of alien languages. Everything appeared normal, but Marcus noticed something that made his stomach clench. The steady vibration of the engines was becoming irregular. Engineering Bay 7 was the heart of the station's power systems. When they arrived, Marcus saw Captain Nexus floating in her specialized mobility tank. The aquatic Thalassian's tentacles flashing colors that Marcus had learned meant extreme concern. Dr. Kreith, the station's lead scientist, was hunched over a diagnostic console, her mantis-like form perfectly still except for the rapid movement of her compound eyes. The primary fusion reactor has suffered a cascading failure, Captain Nexus announced, her translator converting her bioelectric communication into standard speech. 3 of the 4 main plasma conduits have ruptured simultaneously. We are currently operating on auxiliary power only. Marcus felt the floor beneath his feet. The vibration was definitely weaker now. How long do we have on auxiliary power? Dr. Kreith's head rotated 180 degrees to look at him, a movement that still made Marcus slightly queasy. Approximately 47 hours before life support systems begin to fail. 72 hours until complete atmospheric loss. The materials that don't exist, Vorthak led Marcus to the damaged reactor chamber. The sight was worse than he had imagined. The plasma conduits, each as thick as his torso, had not just ruptured, but had essentially melted. The specialized crystalline matrix that contained the fusion plasma had liquefied, leaving behind twisted metal that looked like abstract sculpture. The conduits were constructed from Altarian crystal steel composite, Vorthak explained, running his mineral fingers over the damage. The manufacturing process requires a gravitational forge and materials that exist only in the Altair system. The nearest replacement components are 17 light-years away. Marcus examined the wreckage more closely. His engineering training back on Earth had emphasized improvisation and adaptation. Human technology had advanced quickly, precisely, because humans were willing to try unconventional solutions. But looking at this level of destruction, even he felt overwhelmed. What about fabricating new components here? Marcus asked. The station has manufacturing capabilities. Dr. Kreith's antennae twitched, which Marcus had learned was the Manthari equivalent of shaking her head. Impossible. The molecular structure of Altarian crystal steel cannot be replicated without specific quantum field generators. Additionally, the plasma temperatures involved require materials with thermal coefficients that simply do not exist among our available resources. Captain Nexus drifted closer in her tank. We have contacted the Consortium Emergency Response Fleet. The nearest vessel with appropriate replacement parts will arrive in approximately 96 hours. Unfortunately, this exceeds our auxiliary power capacity by 24 hours. Marcus did quick mental calculations. Even if they shut down all non-essential systems, they would run out of breathable air before help arrived. 300 lives hung in the balance, and conventional solutions had just been ruled impossible. The challenge of the ages Vorthak's crystalline body darkened slightly, a sign Marcus had learned indicated deep contemplation. Engineer Chen, your species has a reputation for what our databases term unorthodox problem-solving methodologies. The Terran Engineering Academy's submission to the Galactic Technical Database includes several case studies of humans creating functional technology from what other species would consider waste materials. Marcus nodded slowly. We call it jury-rigging or sometimes field engineering. The idea is that any technology can be repaired or replaced using whatever materials are available, as long as you understand the underlying principles. Fascinating. Dr. Kreith clicked. However, this situation involves plasma containment at temperatures exceeding 50 million degrees Celsius. Improvised solutions would seem to violate several fundamental laws of material science. Vorthak's internal light pulsed brighter. Perhaps. But conventional solutions have failed. Engineer Chen, I am formally requesting that you attempt to devise an alternative repair strategy, using only materials currently available on this station. Consider it a test of human adaptability versus the impossible. Marcus looked around the engineering bay at the faces of his alien colleagues. Some showed skepticism, others curiosity, but all showed the same underlying fear. They were all going to die unless someone found a solution that their combined centuries of advanced education said could not exist. Exploring the impossible. Marcus spent the next several hours touring areas of the station he had never seen before. Vorthak had given him access to every storage compartment, maintenance section, and waste processing facility on Kepler-7. The other engineers followed at a distance, clearly expecting him to eventually admit defeat. The station's recycling centers were treasure troves of discarded technology. Marcus found broken mining equipment, obsolete computer components, damaged hull plating, and thousands of other items that had been deemed too damaged or outdated for continued use. Most species, he realized, had very specific ideas about what constituted useful materials. Humans, on the other hand, had learned to see potential in everything. In Waste Processing Unit 12, Marcus discovered something that made him pause. A collection of damaged thruster nozzles from decommissioned mining drones were scheduled for molecular disintegration. The nozzles were made from a titanium ceramic composite designed to withstand the heat and pressure of rocket exhaust. They were not rated for fusion plasma, but they were remarkably heat-resistant. These nozzles, Marcus asked Dr. Kreith, who had been following his exploration, what's their maximum operating temperature? Approximately 8,000 degrees Celsius, she replied. Adequate for chemical propulsion, but utterly insufficient for plasma containment. The differential is more than 6 orders of magnitude. Marcus nodded, but continued collecting the nozzles anyway. He also gathered lengths of high-conductivity cable, magnetic field generators from old mining equipment, and several containers of industrial coolant that had been replaced during routine maintenance. The skeptical gallery, by the station's evening cycle, Marcus had assembled a collection of materials that looked like a junkyard in the middle of Engineering Bay 7. Vorthak observed the growing pile with what Marcus interpreted as polite bewilderment. Engineer, Chen, Vorthak said carefully, I recognize many of these components. Individually, none possess the thermal resistance necessary for fusion plasma containment. How do you propose to overcome this fundamental limitation? Marcus was examining the damaged reactor housing, measuring clearances and studying the melted conduit connections. Well, the problem isn't really the temperature resistance of individual components. The problem is heat distribution and containment. Duration. Captain Nexus's tentacles flashed confusion colors. Please elaborate. Marcus picked up one of the thruster nozzles. This nozzle can handle 8,000 degrees for extended periods. Fusion plasma is much hotter, but what if the plasma doesn't stay in contact with any single component for very long? Dr. Creeth's compound eyes focused intently on him. You are suggesting some form of dynamic heat distribution system? Something like that, Marcus replied, though he was still working out the details in his head. On Earth, we have a saying, if you can't make something strong enough, make it smart enough. The original conduits were designed to contain plasma through brute force material properties. But what if we contained it through intelligent redirection? The alien engineers exchanged glances that Marcus was learning to interpret as professional skepticism mixed with curiosity. They had centuries of experience telling them that what he was proposing violated fundamental engineering principles. But they also knew that humans had a history of making the impossible work anyway. The first steps Marcus began by carefully dismantling several of the thruster nozzles, studying their internal structure. The titanium ceramic composite was layered in a specific pattern designed to channel exhaust gases efficiently while dissipating heat. It gave him an idea that was either brilliant or completely insane. Working through the night cycle, Marcus began welding sections of the nozzles together in a complex serpentine pattern. Instead of creating straight conduits like the original design, he was building a maze that would force the plasma to follow a much longer path through many small chambers. Vorthak observed the construction process with growing fascination. You are creating multiple thermal barriers. The plasma will transfer some of its energy to each chamber wall, reducing its temperature as it progresses through the system. Exactly, Marcus replied, sweat dripping from his forehead as he worked the welding torch. And by the time it completes the circuit and returns to the beginning, the first chambers will have had time to radiate away the heat they absorbed. It's like a thermal relay race. Dr. Creeth was taking detailed notes on everything Marcus did. This approach contradicts standard engineering doctrine. Increasing the complexity of a system typically increases failure points and reduces reliability. Marcus paused in his welding to wipe his brow. True, but sometimes complexity is the only way to achieve something that's impossible with simple solutions. Besides, humans have been over-engineering things for so long that we're pretty good at making complex systems work reliably. The other engineers continued to watch and question, but Marcus could sense their skepticism beginning to shift toward genuine interest. They were witnessing something their education had taught them was impossible, but their instruments were showing that it might actually work. As the station's artificial dawn began to brighten the corridor windows, Marcus stepped back to examine his creation. What had started as a collection of scrap metal and discarded components was now beginning to look like a functional piece of engineering. It was ugly, complex, and completely unlike anything in the standard Galactic engineering manuals. But Marcus thought it just might save all their lives. The breakthrough innovation, the night that changed everything, the station's night cycle found Marcus Chen alone in Engineering Bay 7, surrounded by the soft glow of welding torches and the steady hum of fabrication equipment. The other engineers had retired to their quarters, leaving him to work in solitude with his collection of salvaged components. Outside the bay's viewports, the stars wheeled slowly as Kepler-7 continued its rotation, oblivious to the drama unfolding within its metal walls. Marcus had been working for 18 straight hours, fueled by determination and the growing certainty that his unconventional approach might actually succeed. The serpentine network of connected thruster nozzles had grown into something that resembled a metallic coral reef, more than traditional engineering. Each junction was carefully calculated, each turn precisely angled to maximize heat dissipation, while maintaining plasma flow integrity. The key breakthrough had come when Marcus realized that the magnetic field generators from the old mining equipment could be repurposed as plasma guides. By creating a dynamic magnetic field that constantly shifted the plasma's position within each chamber, he could prevent any single section of the conduit walls from experiencing prolonged exposure to the extreme temperatures. The science of making. As Marcus worked, he found himself thinking about his grandfather, who had been a mechanic during the early days of space exploration. "Boy," his grandfather had often said, Remember that fancy equipment breaks down just as fast as simple equipment, but simple equipment is easier to fix with whatever you've got lying around. The principle Marcus was applying was essentially the same one humans had used throughout their history. When you cannot overpower a problem, you outsmart it. The fusion plasma was far too hot for any available materials to contain directly. But by constantly moving it through a network of smaller chambers and allowing each chamber time to cool between exposures, the impossible became merely difficult. Dr. Kreeth appeared in the doorway during the deepest part of the night cycle. The Manthari scientist moved with the characteristic silence of her species, but Marcus had become accustomed to her presence during his work sessions. "Engineer Chen," she said softly, "I have been analyzing your construction methodology. The mathematical model suggests that your approach should not work. Yet the preliminary thermal simulations indicate that it will work remarkably well." Marcus looked up from his welding, his face mask pushed up to reveal tired but determined eyes. "That's the thing about human engineering, Dr. Kreeth. We don't always worry about whether something should work according to theory. We're more interested in whether it does work in practice." Dr. Kreeth's compound eyes studied the complex network of tubes and chambers that Marcus had constructed. "Your species appears to have developed an intuitive understanding of systems, engineering that our formal education methods do not adequately address." The moment of truth by the morning cycle, Marcus had completed what he privately thought of as the most ambitious piece of jury-rigging in human history. The improvised plasma conduit system stretched across half of Engineering Bay 7, a maze of interconnected chambers that looked nothing like the sleek, elegant conduits described in Galactic engineering textbooks. Chief Engineer Vorthak materialized near the construction site, his crystalline body reflecting the work lights in complex patterns. Captain Nexus arrived moments later, her mobility tank gliding smoothly across the deck plates. Other members of the engineering staff began gathering, drawn by curiosity and the knowledge that their lives might depend on the success or failure of this unconventional experiment. "The auxiliary power systems are showing signs of strain," Captain Nexus announced. "We have approximately 12 hours of life support remaining before we must begin emergency protocols." Marcus nodded grimly. Emergency protocols on a space station meant sealing off sections of the habitat to preserve atmosphere for as long as possible. Eventually, even that would fail. This test would determine whether everyone lived or everyone died together. "The system is ready for initial testing," Marcus reported to Vorthak. "I recommend starting with a low-energy plasma stream to verify containment integrity before attempting full-power operation." Vorthak's internal light pulsed thoughtfully. "Agreed. Dr. Kreeth, please monitor all sensors during the test sequence. If Engineer Chen's device fails catastrophically, we must be prepared to implement emergency containment procedures immediately." Beyond all expectations, the first test pulse sent a stream of relatively cool plasma through Marcus's improvised conduit network. The sensors showed exactly what his calculations had predicted. The plasma traveled through the serpentine path, depositing thermal energy in each chamber before moving on. By the time it completed the circuit, its temperature had dropped to manageable levels, and the chambers it had initially heated were already beginning to cool. "Remarkable," Dr. Kreeth whispered, her antennae twitching with excitement. "The thermal distribution is exceeding theoretical predictions. The system is actually more efficient than the original Altarian crystal steel conduits." Vorthak's crystalline form brightened noticeably. "Prepare for full power testing." Marcus felt his heart hammering as the reactor began generating fusion plasma at operational temperatures. The sensors showed the plasma entering his jury-rigged system at over 50 million degrees Celsius. For a moment, everyone in the engineering bay held their breath. The system held. Not only did it contain the deadly plasma safely, but the efficiency readings were extraordinary. The complex path that the plasma followed through Marcus's network of chambers allowed for more complete energy extraction than the original straight-line conduits had achieved. "All systems showing green," Captain Nexus announced, her tentacles flashing brilliant colors of joy and relief. "Primary reactor is operating at 112% of normal efficiency. Life support systems are fully restored." A cheer went up from the gathered engineers, a cacophony of sounds from a dozen different species, all expressing the same emotion. They were going to live. The lesson that changed everything, in the hours that followed, as the station returned to normal operations, Marcus found himself surrounded by alien colleagues eager to understand how he had achieved the impossible. The engineering bay had become an impromptu classroom, with beings who had centuries more education and experience than Marcus, asking him to explain human problem-solving methods. The key principle, Marcus explained, is that humans learned, early in our development, that resources are usually limited. We couldn't always build things the ideal way, so we got very good at building things the possible way. We call it making do or jury-rigging, and it's based on the idea that any problem can be solved if you're willing to think creatively about what materials and methods are available. Dr. Creeth was documenting everything for the Galactic engineering database. Your approach seems to emphasize adaptability over optimization. Rather than finding the perfect solution, you found a working solution using available resources. Vorthak's crystalline body had taken on a warm, golden hue. This methodology could revolutionize emergency engineering protocols throughout the galaxy. Most species become paralyzed when ideal materials or methods are unavailable. Humans, it seems, become more creative. The philosophy of function. Marcus picked up one of the original thruster nozzles that he had modified for the plasma conduit system. My grandfather used to tell me, if it's stupid but it works, it's not stupid. The galactic engineering community tends to focus on elegant solutions that work perfectly under ideal conditions. Humans tend to focus on ugly solutions that work adequately under any conditions. Captain Nexus floated closer in her tank. This approach would seem to require extensive practical experience with improvisation. How does your species develop such skills? Marcus laughed. Well, human technology advanced pretty quickly compared to most species, and we didn't always have time to perfect each generation before moving on to the next. So we got really good at making old technology work alongside new technology, fixing things that were never meant to be fixed and building new things out of old things. We've been jury-rigging solutions for so long that it became part of our engineering culture. Recognition and revelation. The station's intercom crackled to life with an announcement from the command center. This is Captain Nexus speaking to all station personnel. Thanks to the innovative engineering work of human engineer Marcus Chen, our reactor crisis has been resolved. Not only has primary power been restored, but our new plasma conduit system is operating at higher efficiency than our original equipment. Engineer Chen will be promoted to senior engineering specialist, and his methods will be incorporated into our standard emergency protocols. As the announcement ended, Marcus felt a hand on his shoulder. He turned to see Vorthak, whose crystalline features seemed to be arranged in what Marcus had learned was a Zephyrian smile. Engineer Chen, Vorthak said, I have worked in engineering for over 2 centuries. I have seen solutions that were elegant, solutions that were powerful, and solutions that were theoretically perfect. But I have never seen a solution that was impossible according to all established principles, yet worked better than the original design. Your species has taught us something valuable about the difference between knowing what should work and discovering what does work. Marcus looked around the engineering bay at the faces of his alien colleagues. Beings from a dozen different worlds, each with their own engineering traditions and methods, all united in their appreciation for a fundamentally human approach to problem-solving. The new standard in the weeks that followed, Marcus's jury-rigged plasma conduit system became the subject of intense study throughout the Galactic Engineering Consortium. Delegations of alien engineers visited Kepler-7 to examine the impossible device that outperformed technology that had been considered state-of-the-art. The official engineering report, filed by Dr. Creeth, concluded, Human engineer Marcus Chen has demonstrated that complex problems may sometimes require solutions that violate conventional optimization principles. His approach of dynamic thermal distribution through improvised materials achieved superior results using components that individual analysis suggested were inadequate for the task. This suggests that human jury-rigging methodology represents a legitimate engineering discipline worthy of serious academic study. But for Marcus, the real satisfaction came from something much simpler. Every day he could feel the steady vibration of the reactor through the deck plates, powered by a system built from scrap metal and human stubbornness. 300 beings from 12 different species continued their work among the stars, kept alive by a solution that shouldn't have worked, but did. The human way forward months later, as Marcus trained a new generation of alien engineers in human improvisation techniques, he often thought about the lesson his experience had taught the galaxy. That sometimes the best solution isn't the most elegant or the most theoretically sound, but simply the one that gets the job done with whatever resources are available. Remember, he would tell his students, engineering isn't really about building perfect systems. It's about building systems that work well enough to keep people alive and get the job done. Everything else is just decoration. And throughout the galaxy, in emergency situations where conventional solutions failed and resources were limited, alien engineers began to ask themselves a question that was becoming legendary. What would a human do? The answer, more often than not, was something that shouldn't work but does.